Hello and welcome to this session of Introduction to Autonomous System. In the last segment, we introduced the idea of intelligent rational agent, and towards the end we came to the point where there was a need to look at the definition of the problem formulation, or in this case what we call the task environment. Now, there are many ways in which we could define the task environment, but I thought going through an example probably would give us a better perspective, so that when we look at the actual definition, some of the points would make better sense. So, let us consider an example of an autonomous taxi as an intelligent rational agent that we want to design for solving the problem of travel. So, let us say that problem of travel is the context or the environment which we want to define. So, let us say that our problem is the travel, and travel is your environment. Now, in order to come up with its task environment, or let us say problem formulation, so let us first start with the performance measures as to how we would judge the quality of travel. And we all know that we would like the travel to be safe, we would like it to be fast, we would like it to be legal, which means not violate any restrictions, and it should be comfortable. There could be few more attributes that you may want to add, but now you find that these are the kind of attributes that would ultimately get attached to what we call the performance measures. Then we could consider the context in which we are actually executing the travel, and it could be composed of roads, other traffic, pedestrians and customers. They all are ultimately going to be part of the context in which the travel will have to be executed, and they are all part of the problem. The roads, the other traffic we have to consider, the pedestrians, the customers. Now, that brings us to the other idea, sensors. So, in the context of autonomous taxi that we are talking about, the sensors could be cameras, sonar, speedometer, GPS, odometer, accelerometers, engine sensors, a keyboard, touch screen, and there could be many more such devices and the hardware elements which could all ultimately be grouped under the broad category of sensors. Then comes the actuators. We could identify the steering wheel, the accelerator, the brake, various indicator signals, horn, the display, etc. So many things could be there. I mean, you could add a few more actuators to this list. What I am just trying to say is that these are the kind of things that will become part of your problem definition, and in the process will have an impact on your ability to define what we call the task environment. So, if we were to come to a kind of a crisp generic definition of task environment, we find that anything that has a bearing on the success of taxi as an agent, which means the success criteria we have already defined in the form of safe, fast, legal, etc., they all have to be put in the overall box of what we call the problem, and that would then become the task environment for the agent. So, anything that can impact the performance, please note, this is a very encompassing interpretation, that anything which is going to have a bearing, even a pothole for example, which is not a living entity, also has a bearing on the design of the taxi agent. Because if there is a pothole, the agent must be able to identify the pothole and take action to avoid it, because otherwise it will directly go and impact the performance metric of comfortable ride, because the ride then will become uncomfortable. So, you realize that anything which can have an impact on those performance metric is going to have to be part of your task environment. Of course, based on this, now we can start looking at the various categories of task environment, and it is going to be huge and perhaps not possible to be discussed all in this module. So, what we are going to do is that we are going to identify a smaller set of dimensions which are commonly applicable to most problems that we will be looking at, and along those dimensions a specific task environment could be categorized. Please note, these are still fairly generic and will cater to a very large class of problems, and they are going to help us in achieving an appropriate agent design as well as in choosing techniques for implementing the designed agent. So, the implication of these dimensions as well as their definitions are now going to be discussed next. Let us take them one by one. So, the first category which is applicable for various problems that we are considering is defined through these two terminologies called fully observable and partially observable. It essentially refers to the status, and let us try and understand what we exactly mean by this status. So, what we mean when we say an environment is fully observable, if the sensors provide complete access to the state at each point in time, which means that, for example, if I have a camera which is 360-degree camera, many of the cars now are equipped with 360-degree camera, like front camera, rear camera, side cameras. Then through that camera you know completely everything about what is going on. You know in front what is the traffic, you know what is the traffic at the back, you know what is coming on the left, you know what is coming on the right. So, considering all that, you realize that in this case my environment or the road condition is fully observable, which means there is no aspect which is unknown or what we typically call a blind spot. But if there are blind spots, there are sides of the road which we are not able to see or not able to observe, then it is typically termed partially observable. You will find that fully observable environments are useful for the simple reason that at every instant the agent can generate the current condition of the environment or the surroundings, situational awareness, and it need not worry about storing any previous information. But unfortunately, you will find that in reality you never really get fully observable environments. They are going to be always partially observable. Now, to what extent they are observable will entirely depend on the sensors that you use. For example, in a very rudimentary vehicle, you may not have even any camera or sonar. So, you have no awareness except the front traffic, and maybe to some extent if you have a side vision, the side traffic. You have no idea of what is happening at your back, but the rear view mirror does it to some extent. So, you realize that there are going to be blind spots and that will make the environment partially observable. The other category which commonly impacts your agent design is that are you in a single agent environment or a multi agent environment. What we mean by this is that does the scenario involve only one agent that you are talking about, or there are more than one agent within that, because that is going to affect the operation, the actions to be taken, as well as the performance metrics. But then this definition is little bit fuzzy, because it depends on whether the entities involved can be treated as agents or as objects that behave as per the laws of physics, which are well defined. Which means, if the entities involved in that problem can be treated like objects which behave as per the laws of physics, then they are not agents, but they are just objects which have to be negotiated. Otherwise, they have to be treated like agents. So, when we talk about a single agent scenario, we are essentially saying that there is only one entity that is maximizing its performance measure, while all other entities are just objects. For example, if is the only taxi on the road, that is a single agent scenario, there is no other traffic. But if there are other taxis, pedestrians and other objects which are also trying to have their own objectives and trying to maximize their performance, then it is a multi-agent scenario. In reality, most of the task environments will be multi-agent scenarios. The third one, the category that we talk about, is deterministic versus stochastic. So, these definitions are very specific. So, we say that an environment is considered to be completely deterministic if its next state is fully determined by its current state and the action taken by agent, which means we fully understand. What it means is that if I give you an example of the same taxi agent, I know where I am currently or what is my speed at this point, and I know that if I depress the accelerator, its speed will increase by this amount, which means I have a complete idea of what is going to happen if I take this action. All such cases are described as deterministic. Of course, if this condition is violated, then the environment becomes stochastic or random, which means that there is no way of completely knowing the next state, even though you know the action that you have taken, which means your action is not deterministic and the environment itself is not deterministic. In fact, it is found that environments which are partially observable, even though they are deterministic, will generally appear as stochastic. The reason being that you are not able to work out a particular performance metric because you are not observing it. So, it will appear as stochastic because then you cannot take an action to achieve a specific metric. And of course, the real scenarios will always be categorized as stochastic. So, there are really not many deterministic scenarios except synthetic problems. The fourth category in which the environment is reflected is we call episodic versus sequential. The episodic environments are those where a single percept is followed by a single action and the next episode does not depend on the action taken in the previous episode. Please note this, let me explain this a little bit as an example. For example, let us talk about a doctor who is seeing patients in OPD or a quality inspector which is looking at the parts for their defects. All these are examples of an episodic environment, because you can clearly see that a doctor receives a patient as a percept, its case history, and takes an action in the form of a prescription or a treatment plan. The moment that patient goes and the next patient comes, which is the next episode, it has no connection with the previous patient or the previous diagnosis or the previous prescription, and you will find that all such environments are generally easier to handle. But typically in reality, there are many other environments which are sequential in nature, where the current actions impact all future decisions, and the current decisions are driven by actions that were taken in the past. For example, playing chess. Your current move depends heavily on the moves that you had made earlier, and whatever move that you make now is going to impact your subsequent moves. Similarly, driving a car is a sequential environment, because any action that you take will have an impact on what future decisions you will take. For example, if you take a detour, then all the driving decisions will be driven by the decision that you took about the detour, and they are obviously more complex to deal with. The next attribute which gets attached to the environment is static versus dynamic. Static environments are those that do not change during the period in which the agent perceives, decides and acts, else it is termed dynamic, which means that you observe a particular thing, you take an action, and during that period whatever you have observed remains valid. So, the counterpoint is that if the environment is dynamic, then you have perceived something, and by the time you take an action, maybe that thing has changed. For example, if you are driving and you see from a distance a signal which is green at the moment, so you are moving at a particular speed. So, that is the action that you have taken, and by the time you take that action of accelerating, the signal becomes yellow. So, that previous information is no longer valid. The environment is dynamic, and by the time you come closer, it actually becomes red. So, not only you need to slow down, but you also need to stop. So, you realize that the dynamic environments are going to be a bit more difficult, because your actions will have to be taken on the fly, they will have to process the information at a reasonable rate. Sometimes the environment do not change with time, but your performance standards change. For example, suppose you have a timeline to reach a destination, and suddenly the time gets advanced, saying that you need to reach early. The environment has become dynamic, you need to take actions which are now going to be driven by a changed performance metric. So, they are typically termed semi-dynamic. Of course, it is intuitive to realize that static environments are easier to work than dynamic. Then we have another categorization in the form of discrete versus continuous. In this context, it is worth noting that discrete or continuous are essentially attributes of the state of the environment in the way that time is handled, as well as the nature of the percepts and actions of the agent, which means is the time a continuous variable or time is a discrete variable. For example, if you are going to monitor something at regular intervals, for example, if you are looking at the road continuously, then obviously it is a continuous system. But if you are looking at your conditions at every 1 second, every 2 seconds, every 5 seconds, then it is a discrete system. Of course, In the chess, the states are discrete, while in the moving car, they are continuous. In fact, it is also found that sometime when the changes in the state, even though discrete, are available over smaller time intervals, a discrete environment can be treated like a continuous without much penalty. The last idea is known versus unknown. Now, this is where we have a small issue. The known or the unknown attribute is not really for the environment per se, but actually the state of the knowledge base of the agent, which means we are saying that environment has well defined laws of physics. So, it is not that it cannot be known, but the agent does not know it for whatever reason. So, if the agent does not know it, as far as the agent is concerned, it is unknown even though the real environment is known. So, for a known environment, the outcomes for given actions are known, but for an unknown environment, agent now needs to learn to make good decisions because it does not know. It still has to come up with good decisions in an unknown context. Please note that this is different from observability. Observability says that you are not in a position to observe it for whatever reason. But when you say it is unknown, you do not know the laws of physics which will govern the process. It could be probabilistic, it could be statistical. You have no idea how that process is proceeding. So, if we look at the overall impact of these dimensions, you can clearly see that they all are going to have a direct bearing on the design and implementation of the agent. Agent which is intelligent and rational, which is supposed to accomplish a task in the best possible manner in relation to expectations. In fact, it has been found that the hardest problem that any agent can come across, and those agents are very difficult to design, are in the case of an environment which is partially observable, multi-agent, stochastic, sequential, dynamic, continuous and unknown. Which means if all of these attributes are part of an environment, that is the hardest problem that the agent needs to solve. In fact, you will find that taxi driving is all of these. Driving in a rented car in a new country with unfamiliar geography and traffic laws will take it to the next level of complexity. So, now you realize how difficult this problem is, and that is why the current effort in trying to design autonomous taxis, why is it taking so much of an effort and why it is not proceeding at the rate at which people are expecting it, why it is moving only very slowly, because it is the hardest problem to solve from the environment point of view, particularly if you have a rented car, which means car is unknown, country is unknown, geography is unknown, traffic laws are not clear. It is a complete mess, and that is the kind of problem that people are now currently looking at in designing the autonomous systems to work in such environments. There are issues of multiple environments. In fact, we have not even touched upon this problem, that it is not that a particular agent will work in only one environment. The same agent will also need to work in different kinds of environments. I will just give you an example. For example, as a taxi agent, you will not only need to drive on highways, but by lanes, congested areas, during daylight, darkness, snow, rain, bad roads, all of them are going to be different environments, and they could happen within the same kind of a domain, that within the same driving session you may encounter all of these. So, there are multiple environments which have to be negotiated, and you will find that these are the kind of things that we will need to train the agent for, so that the performance measures are still reasonably met. So, to conclude, Task environment is nothing but various attributes and features that together define the problem. We also note that environment complexity directly impacts the nature of the problem and consequently the design of intelligent rational agent which is expected to solve it. So, with that we come to the end of the today's session. In the next session, we will start delving into the basic process of the design of an agent and look at the various ways of solving a problem. So, bye for now and see you later. Thank you.